All right, everyone, here comes our first lesson on our COVID-19 extravaganza. Woo! As you can see, I've already written out a question for you to consider. A ball was thrown into the air at 30 meters per second. How long will it take the ball to reach a height of 25 meters? For those of you who find ball too boring, insert your own object, such as panda, if you would like, but I leave that up to you. So the idea that we have here is that we've got this object that's being thrown up. It comes up to the top, reaches a velocity of 0, and then it comes back down over here like this. And we do know that the starting velocity at the beginning is 30 meters per second. So down over here, we know that the starting velocity, V naught, equals 30 meters per second. And I have to figure out this program again. Okay. So that's down over here. We also know that the starting velocity, or the velocity up at the top, is 0. So I'm going to copy that over here. Whoa, what am I doing? Oh, we want this over here to be 0. Oh, I made that a long way around. All right, well, we'll figure this out. Equals 0. Okay, now one of the things to note here is that it says how long does it take the ball to reach a height of 25 meters. So that's going here all the way up, but we don't actually know where 25 meters is. We cannot assume that 25 meters is up here at the top. It's going to be somewhere else. So, for example, 25 meters might be right about there. That might be 25 meters. So, I actually don't exactly know where it is, which gives us a bit of a problem in the fact that we cannot assume that, we cannot assume that the 25 meters is up to the top, and so that our ending velocity is 0. So that gives us a bit of a problem, and really does not help us a whole lot that we know this piece of information. But we do know, of course, that the acceleration is going to be 9.8 towards the center of the Earth. So if we consider trying to figure out the time, hopefully you can recognize that we can use equation 4. Oh, sorry, hold on. There we go. Equation 4, where we do have the distance or displacement of 25 meters going this way. We have the starting velocity of 30, and of course we know that the acceleration is going to be negative 9.8. So when I place in the values into d equals v naught t plus 1/2 et squared, we get the following. 25 equals 30t plus 1/2 of negative 9.8 t squared. Of course, we'll do the math that we can, and really all we can do is take the half of the 9.8 and we'll get 25 equals 30t minus 4.9 t squared. We'll put this into standard form, where we're going to move the 25 over to the other side and put the t squared item first. And we get the following. Negative 4.9 t squared plus 30t minus 25 equals 0. So if you remember from last week, this is a quadratic, and you have two options. One is to try to complete the square, and the other is to use the quadratic formula. So we're going to try to use the quadratic formula. So if you remember, the quadratic formula is t, in this case t, normally x, but t equals minus b plus or minus the square root of b squared, subtract 4ac, all divided by 2a. As a reminder of the quadratic formula, the value in front of the t squared is a, the value in front of the t is b, and the value that's on its own is c, including the signs. So when we place those into the quadratic formula, we get the following. So now we can see that we've placed in our b of 30 into here, so it's negative 30. We're going to put it here to give us 30 squared. We're going to take our 4.9 and put it in here, and our negative 25 and put it in here. When we do the math that we can, we get the following. We now have t equals negative 30 plus or minus the square root of 900, that's the 30 squared, minus 490, that's the negative 4 times the negative 4.9 times the 25. And then of course on the denominator we get negative 9.8. Again, we'll combine what's underneath the square root. And so now we have 410 underneath the square root. And then I hope you can see that we'll square root that and we'll go on to our next step. So now we have t equals minus 30 plus or minus 20.2 divided by negative 9.8. If you remember, what we need to do now is we really need to deal with this equation twice, once where the 20.2 is positive and once where it's negative. So as you can see here, when we add these and divide by negative 9.8, we get exactly 1 second, which is kind of interesting. And so it looks like that, oh, we've got a positive answer, and that was the amount of time for it to reach this. Great. Well, let's check out the negative version of this, and let's see what we get. So as you can see, we actually get another time that's positive again. It's not that one's negative and one's positive. Both of them are positive. So how do we know which is the correct one? Well, the fact is that both of them are actually correct. The question asks, how long does it take the ball to reach a height of 25 meters? It doesn't say if that happens to be on the way up or on the way down. So if we follow the path of the ball, or panda in your case, it reaches this height of 25 meters once on the way up, continues to the top, comes back down, and reaches that height again of 25 meters on the way down. Because this here is technically a displacement. It's not a distance. All the question is asking them, how long does it take for the ball starting from here with this starting velocity to reach this height? Well, it does that 2 different times. On the way up, it takes 1 second from the beginning. So this is 1 second. On the way down, it takes 5.12 seconds. That happens to be from the beginning all the way to the top and then back over here. That is 5.12 seconds. So in fact, we have a case where both of these are the correct answer. Let's see if I can do this. Is it going to make a box for me? It's supposed to make a box. Oh, it does. Oh, but of course the box is filled. How do I change this now? Let's see. Arrange, send to the back. There we go. And now I've got it the right size. Oop. All right. So I hope this is helpful. When you are going through the assignment that I give you today, which is a review for this unit, you will notice that there might be a question that revolves around this. There is also a question on the assignment that you were supposed to work on today. If you did not catch that, the fact that there are 2 possible answers, you may want to double check that And if you've already done the question and you didn't catch it, just send me a, redo that question again, and just send me a picture of that one question if you feel that you have forgot or that you missed this. That this type of scenario actually has 2 different times. Those of you who are trying to solve this without using the quadratic, I hope you can recognize that figuring out from here to here might be relatively easy to figure out the time. You have the starting velocity, you have this, and what you can do is you can really view the opposite side from here to here as well, if that's helpful. You're just going to need to find what the velocity is at this point. So you can use equation 5 to use the starting velocity, the acceleration, the displacement to figure out the velocity here, and then use equation 3 with your starting velocity, your new velocity that you just found here, the acceleration, and figure out the time. Then what you can do is you can figure out the time from here to here, multiply by 2 to get this side and that side, and add it to this time. So it's as if you have 1, 2, 3 sections to figure out. You can try that out yourself on this particular problem and try to get the 2 answers of 1 second and 5.12 seconds. All right, I hope this lesson was helpful for you guys. Take care. Feel free to send me an email. There's a few emails that I've already been able to answer, and we'll see you guys soon. Bye.